exploring quadratic graphs. So we're going to start with standard form of quadratic function. I think you already know what a standard form is, right? Anybody know what standard form of a quadratic function would be? Remember how you find your ABCs? So it's y equals ax squared plus bx plus c is the standard form of a quadratic function. Okay? And function being an equation. Alright, so you do have to know this. But what we're dealing with today is when b is 0 and c is going to be 0, or when b is 0, we're going to be graphing those. Now, every function has a parent function, so the quadratic parent function is y equals x squared, where a is 1, b is 0, c is 0. This is the parent. Everything else derives from this. So I could add a 3, so then it would be y equals x squared plus 3. It changes the graph, okay? And also the shape of the graph is going to change. But now, do you guys remember what shape y equals x squared makes?
No.
A U. Okay? But now, starting today, I want you to use this proper terminology, and this graph is called a parabola. Okay, so we are going to be graphing a parabola.
Can you move it down?
Yep. So here's my x and y axis. All right. Oh, my line is crooked.
Yeah, crooked lines mean a crooked line.
Okay. So I have a point that goes through there. Here's -1, here's -2, here's 1, here's 2. When it's 1, it's 1. When it's -1, and then 1, 2, 1, 2, 3, 4. Here's 4. So at -2 is 4, and here is also 4. So it makes that nice rounded bottom, and we make this shape called a parabola. So this graph is called P-A-R-A-B-O-L-A, parabola. Okay? Parabola. Alright, this is the name of the graph. So every quadratic function makes a parabola. Okay? Now, so now we're going to explore. This point right here, okay, we call that point, and I think I went over this before, it's called the vertex. Okay, the vertex. And vertex actually is a point. And when I ask for the vertex, you got to give me an ordered pair. Okay, and if you notice, this parabola is very symmetric. So there, I could put an imaginary line that will go through right through the middle of the parabola. Okay, and it makes this side a mirror image of this. So if I were to take this and fold it in half on this imaginary line, okay, this side would match exactly to this side. So this side is a mirrored image of this side. All right, we call this line right here, that imaginary line, to be axis of symmetry, because it makes this parabola symmetric. Okay, and this axis of symmetry is a line. So when I ask for axis of symmetry, you have to give me an equation of that line. Do you guys remember what kind of equation gives you an equation of a vertical line?
No idea.
You guys remember that when we did linear functions? What kind of equation gives you a vertical line? No, not y equals x.
Oh wait.
X is something, Y is nothing.
It's x equals something. It's x equals a number. So if you notice, this one goes through x equals 0, so this line is x equals 0. Okay? It is a line. And I'm going to use the acronym AOS because I'm not going to write axis of symmetry every time. So AOS stands for axis of symmetry. And it is an imaginary line that divides the parabola in half.
Wait, what's that stand for again?
Axis of symmetry. AOS. So when I ask you to find the axis of symmetry, sometimes I would say, find the AOS. And when you're finding the AOS, you're giving me the equation of a line, so it has to start with x equals something. So what if I had a axis of symmetry that went through here? What would be that equation?
2.
X equals 2. Okay, not 2. You don't say it's 2 because 2 is just a number. But I want an equation of a line, so it has to be x equals whatever that number is. And the vertex is a point, okay? So you give me an ordered pair, all right? So now let's talk about what happens in the equation. If I gave you, so y equals ax squared plus bx plus c. Now, if a is greater than 0, that means that a is going to be positive value, isn't it? When a is positive, my parabola goes up like this. So it's an upright parabola, okay? And the vertex is right here. Okay, vertex is right here. This is my vertex at xy. Oh, what would be the vertex for this parabola? What order pair?
0, 0.
0, 0. So this would be 0, 0. That's what the vertex would be. This one, so when a is greater than 0, when it's positive, when a value is positive, then my parabola goes out like this. And this vertex is a minimum because it's the lowest point of the parabola. I have points all along here, and this will be the lowest point. So we call that point the minimum. Okay? Now, if a is less than 0, that means a is what? Negative. Yep, negative. That means my parabola will be upside down parabola. Okay, and then the vertex will be up here. That will be my vertex at xy. But that vertex, instead of being a minimum, it will be my maximum. Bless you. Okay, so everyone understand? So in your assignment today, I'm gonna say locate the vertex. So you give me an ordered pair, and I'm gonna ask you, is it a maximum or a minimum? You would tell me if it's upside down parabola, right? If it's a is negative, then it is a maximum. If it's a is positive, it's gonna be a minimum. Okay? Any questions so far? No. No? Okay. Now, Now remember, when a is positive, the shape changes, the way the parabola goes. But if a is small value, all right, we're not talking about the positive and negative, we're just talking about the a value, okay? My parabola is wide, and it gets wider the smaller the value becomes, and you'll see, all right? And if a is bigger number, big value, it gets narrower. So the bigger the a it gets, right? So if a is 10, it would be very narrow compared to if a was 2. Okay, and if this a was a half, it'd be really wide. All right? So smaller the value, the wider it is. The bigger the value, the narrower it is. Okay? Any questions? All right, ready for your examples? I got 5 examples, but you tell me if I need to do one of the examples or not, okay? All right, here's example number 1. So, like I said, you're going to be identify the vertex. We're going to identify the vertex. And you're going to tell me whether vertex is a maximum or a minimum. Okay, you ready? And I think I should just give you one of these, right? So let's graph. Now they're going to give you the graph, so you don't technically have to graph it. It's going to be given. So here's 1, here's 2, and then 1, 0, 0, 1, and then -1, -2, and 2, and 3. So my parabola looks like this. Okay? 1, 2, 1, -1, 2, 3, -1. Okay. Alright. Does everybody have it?
Yep.
Alright. Okay, Francis. Where's the vertex?
1, 2.
1, 2. And is this vertex a maximum or a minimum?
Maximum.
Maximum. And that's what you're going to be doing today.
That's it.
That's it. So if this question looks like this, that's all you're doing. This is going to be given. Okay? But you don't have to answer this, but if I ask you to find the axis of symmetry, what would be the axis of symmetry?
1, 8,
X equals 1. Because here's my imaginary line that divides the parabola in half. So this, which is my AOS, axis of symmetry, and it is an imaginary line, so it's at X equals 1. Okay?
Wait.
And go ahead.
Oh, so it's wherever that line goes?
Mm-hmm. At X equals 1. Alright, so that's the equation of the axis of symmetry. Any questions on this? No? Okay, example number 2. Now we're going to graph. So today we are going to graph by making a table. Okay? Starting tomorrow, we're going to graph without making a table like we did with the linear functions. Remember, we start with making a table, drawing a line, but then after that, you learn what the slope and the y-intercept was, so you graphed it that way. Same way with this. So we're going to start with this. Now, the points I want you to use 5 points. Most of the time, I want you to use -2, -1, 0, 1, 2. But when a is a fraction, right? A is 1/3. I want you to match the denominator. All right? So the points I'm going to use are -3, -1, 0, 1, 3. That's what I'm going to use. Okay? Because most of the time, I don't want to end up with a fraction when I calculate. Yep. There we go. Thank you. So now my function is 1/3 x squared, and I'm going to locate my y value. Okay? Now, a is 1/3, right? Everybody agree? Is this parabola pointing up or upside down? It's positive, so it's going to be, your parabola should look like this, upright. Okay, that's the first thing that you should check. Is it going to be pointing down or pointing up? And my vertex would be at the top or the bottom. That's what you're looking for. This one, the vertex is at the bottom. Okay? All right, let's plug it in. Remember, you're still using your order of operations, so 1/3 -3 squared. All right, what's -3 squared?
9.
9. So you do this first, so it'll be 1/3 times 9 over 1. And what's 1/3 times 9 over 1?
3.
3. So -3, 3 is the point you're going to locate. Okay? Or I could say 3 goes into 9 3 times, and so 1 times 3 is 3. All right, 1/3 times -3 squared. I mean -1 squared. What's -1 squared?
1.
1. This is 1, and 1 times 1/3 is 1/3. Okay? 1/3 times 0 squared. What's 0 squared?
0.
0. 0 times 1/3 is?
0.
0. And then we're going to go 1/3 times 1 squared. 1 squared is?
1.
And 1 times 1/3?
1/3.
1/3. Alright, so this is also 1/3. And then 1/3 times 3 squared is 9. So 1/3 times 9 over 1 is also 3. So now I'm going to show you something right here. If you notice, because this is symmetric, because it's a parabola, see right here, 3 3s, they match, this match, there's my vertex. Okay? So make sure that when you do your table, it has to be symmetric. Alright? There we go. So let's graph. y-axis, x-axis here is -1, -2, -3, -2, -1. And then here's 1, 2, 3, and then 1, 2, 3. There we go. All right, -3, 3. So -3, 3 is right here. Okay. And then I got -1, 1/3. Well, here's 1. 1/3 is about right here. That's 1/3, so it's about right there. And then 0, 0 is right here. And 1 and 1/3 is right here. See how it's symmetric? And then 3 is 3, so it's right here. And if you notice, it makes that nice rounded bottom, and there is my parabola. And see how wide this is? See how wide? Okay? It's because A is a very small number. The smaller the A value, the wider it is. Bigger the Y value, the narrower it is. Okay? So any questions with this?
No.
Okay. Example number 3.
We don't have to name the vertex.
Oh, you know what? Why don't we? Where's my vertex?
0, 0, 0.
And my axis of symmetry? Oh, I'm sorry. You said vertex is a max or min? Minimum. That's my minimum. And here's my axis of symmetry, right? What is that equation?
X equals A.
X equals
A 0.
0. There's my axis of symmetry. Okay? Who's on the test? I'm going to have you label everything. Just like this. Okay? All right. Example number 3. List function from widest to narrowest. Goodness, that's a hard word to say.
You could just say most narrow.
Y equals 1/2 x squared. Y equals -3x squared. And y equals -x squared. Alright, you tell me which one is the widest. 1/2. Remember, small, there's my A. So my widest would be y equals 1/2 x squared. What's next?
Negative x. Or y equals
-x squared. We're not looking at the signs, we're just looking at the numbers. Negative makes it upside down. So this one's upright, this is upside down, this one's upside down. We're just looking at the numbers. 1 is smaller than 3, so this will be wider, so y equals -x squared. And then y equals -3x squared will be the narrowest. Everybody understand?
Mm-hmm.
Okay. Any questions so far? Okay, you tell me if I need to do this example. This is example number 4. Would you be able to graph this without my help? Graph y equals 3x squared minus 2.
Yeah.
Would you be able to do it?
Do it.
Yeah.
You gotta make a table. This one I will use -2, -1, 0, 1, 2. Do I need to show how to do this one?
No. Because wouldn't that be here?
3x squared minus 2. That will give me my y.
Wait, so are we doing this one?
So -2, -1, 0, 1, 2. Those are the points I want you to use for now. Because this is not a fraction, so those are the numbers I'm going to use. If it's a fraction, it's got to be the multiples of the denominator. Okay? So when I plug it in, 3, -2 squared minus 2. Exponents first, then multiplication, then subtraction. Order of operations. What's the -2 squared?
4.
4. And then 4 times 3 is? 12. And 12 minus 2 is? 10. So everybody understand?
Yeah.
Alright, then 3 times -1 squared minus 2. What's -1 squared?
1.
1 times 3?
3.
Minus 2?
1.
0 squared?
0.
0 times 3?
0.
Minus 2?
-2.
And if you notice, this is going to be symmetric, right? So this should be 1 and this should be 10. Okay? And everybody knows how to plot this, right?
Yeah.
Okay, so I'm just going to plot the three main ones in the middle. So here's the vertex, 0, 0, negative 2. 0, 1, 2, negative 2. Here's that point. And then I got negative 1, 1, negative 1, 1, and 1, 1. And then I guess I could go all the way to 2 and negative 2, but it's way up here. So I'm just going to do this. Make sure when you're doing your parabola, don't make it a V, make it a round at the bottom. So make it a little smiley face and have it pointing up. And see how narrow this is compared to the 1/3 graph that we did? See, 3 is bigger than 1/3. So this is narrow, right? Then look how wide this is, and look how narrow this is. Because the A is 3 here and A is 1/3 here. Okay? Any questions? All right, I'm ready for the last one. Word problem. I should do a word problem, right?
No.
All right, I have a monkey. Why are you laughing? Monkey drops an orange.
Might be like a banana.
Nah. From a branch. That's why he throws it, because it's not a banana. 26 feet above ground. What's so funny?
Because you're talking about a monkey.
Stop talking about a monkey. Everybody likes a monkey, right? The force of gravity causes the orange to fall toward the earth, right? When we're dealing with word problems like this, and we're talking about an object that's being thrown up in the air or thrown down to the ground, the equation is given by, ready, H equals negative 16t squared plus C, where
16.
that's the gravity. What is the gravity in meters per second? 9.8. This is in feet per second, okay? Feet per second squared. H stands for height of the object. T stands for the time in seconds. This is in feet. And C stands for the initial height. What was the initial height of the orange?
26 feet.
26 feet. So C should equal 26 feet. So we're going to put that equation together. But everybody understand this is the basic equation. All right. H equals negative 16t squared plus C. So the equation for this situation will be H is equal to negative 16t squared plus 26. That's the equation we're working with. Okay? Once we have that equation, I want you to graph. So we're going to be graphing. So nothing different than example number 4, right? So we're going to make a table. T. Now remember, T is time. Can time ever be negative?
No.
No. So we are just going to use 0, 1, and 2. That's it. All right. This is the only time you use 3 points. Other times I want 5 points. Right. And my function is negative 16t squared plus 26, and I'm looking for the height at those times. So at t equals 0, how high was the orange?
26.
So this will be automatically 26, because look what happens when I plug in 0. Negative 16 times 0 squared plus 26. What's 0 squared?
0.
Times negative 16.
Zero.
0 plus 26 is
26.
26. That's why the initial height is 26 at t equals 0. Okay. Next one is negative 16 times 1 squared plus 26. 1 squared is 1. 1 times negative 16.
Negative 16.
And negative 16 plus 26?
10.
10. And then at t equals 2, what's 2 squared?
4.
4. 4 times 16?
64.
Negative 64. And negative 64 plus 26 is? Negative 38. That means that if there was a hole in the ground, the orange will be in the ground, 38 feet under the surface. Okay? And because this is a word problem, we only graph the first quadrant. Okay? So this is the time, this is the height of the object. Alright? And here's t equals 0, here's 1, here's 2, and so on and so on. That's the time in seconds. Okay? Now, because the number is so big, I'm going to put a break in there. So here's my break. And I'm going to start at 10. And I'm going to go up by 2s. 2, 4, 6, 8, 10, 20. 2, 4, 6, there's 26. So far, so good? Okay. So now my first point is 0, 26. So there's 0, 26. 110. And 2, negative something is the way down there. So I'm just going to now make it a parabola. And we're just going to bring it down. And it's going to go toward the ground. So we're going to stop at the x-axis. And my graph will look like this. Okay, that's the graph.
Maximum.
Here's my vertex. So what the vertex is telling you at t and h, right? At t equals 0, my maximum height is at 26 feet. Maximum. Maximum height. Okay? And later on, we're going to learn right here what that point is. That's when the ball hits the ground. And we're going to figure that out in, I'm going to say, section 5. Right? But everybody understand how to graph this using a table and labeling, right? Any questions? No. All right, I'm done.